Welcome to Mrs. Z's Chemistry. This is the first video of Chapter 1 called Essential Ideas, where the first topic is called Chemistry in Context. What is chemistry? Well, let's back up a little and learn the context of how modern chemistry developed. So throughout human history, people have tried to convert matter into more useful forms. So for example, back in the Stone Age, people chipped pieces of flint into useful tools and carved wood into other tools, statues, and toys. These endeavors involved changing the shape of a substance only without changing the substance itself. But as our knowledge increased, humans began to change the composition of the substances as well. And so this is how clay was converted into pottery, or hides were cured to make garments, or copper or iron ores were transformed into copper and iron tools and weapons, and even grain being made into bread. Humans began to practice chemistry when they learned how to control fire and use it to cook, or make pottery, or smelt metals. And then they began to separate and use the different specific components of matter. Also, a variety of medicinal drugs, such as aloe, myrrh, and opium, were used and isolated from plants. Or food coloring, or dyes, such as indigo, were extracted from plant and animal matter. Metals were combined to form alloys, which we'll learn that an alloy is just a solid solution. So, for example, copper and zinc were mixed together to make bronze. And more elaborate smelting techniques produced iron. Alkalis were extracted from ashes, and then that's how soaps were prepared, by combining these alkalis with fats. Alcohol was produced by fermentation and purified by distillation. And so all of these attempts to understand the behavior of matter can extend as far back as like 2,500 years ago. And some in the ancient Egyptian cultures and Chinese and Eastern Mediterranean, a lot of people tried to transform ordinary metals into gold. And this is called, or these people were called alchemists, and this pursuit is called alchemy, trying to turn ordinary base metals into what they called noble metals, such as gold. So then from alchemy came the historical progressions that led to modern chemistry. This is how we have isolated more and more drugs from natural sources, or metallurgy, or even the dye industry. Today, chemistry continues to deepen our understanding and improve our ability to harness and control the behavior of matter. Something called the penny demo is where we can see that a normal average penny, copper penny, can be turned into what looks like a silver penny and then turned into what looks like a golden penny. This is a good demo to understand the differences between observations and inferences. We can observe the penny changing color, but then an inference is a conclusion we can reach on the basis of the evidence that we see the color changing, and also reasoning. So we might reason that it's probably not actually turning into silver or gold, as we can assume that if it was that easy to turn ordinary copper into silver or gold, that gold wouldn't be quite as rare or as expensive as it is today. So, what is chemistry? Chemistry is often referred to as the central science because it is connected to a vast array of other disciplines. So what is chemistry? Chemistry is the study of substances, their properties, and how they can be transformed. Another way to put it is that chemistry is a branch of physical science that studies the composition, structure, properties, and change of matter. Matter can be described by physical properties and chemical properties. A property is just a characteristic of a substance. A physical property would be talking about the color, hardness, size, or the weight or mass of the substance. And a chemical property is how that substance reacts or doesn't react with other substances. So in order to come up with a hypothesis, we would need a question. And in the context of the penny, our question is, well, is the penny actually turned into silver or gold? A hypothesis is one of the many possible answers to that question. It's a testable explanation for an observation. Now, this question is rather simple. It's essentially a yes or no question. So one of the possible answers is either yes, it actually did turn into silver and gold, or no, it did not. We could then come up with a prediction saying if our hypothesis is true, so say our hypothesis was that yes, the penny was turned into gold, then our prediction could be if the penny was turned into gold, then when we test the density of this golden penny, the density should come out to the same as the textbook value density for gold. And then that's how we can actually have a testable hypothesis, and we can do some experiments and find out the density of the penny and learn whether or not the density matches the textbook value for gold, and that can help us determine whether our hypothesis is true or not. So we'll talk more about hypotheses and the scientific method in a later lesson. But for now, I want you to know something. Chemistry is very difficult for most people, and it is very important that you ask lots of questions. And this is because successful people ask better questions, and as a result, they get better answers. You should be persistent in asking questions until you are fully satisfied you understand what's happening. So don't be afraid to rephrase your question if you're not completely sure that you understand the answer. Smart kids ask questions. And not only do smart kids ask questions, smart kids also go to tutoring to ask their better questions and gain a deeper understanding of chemistry. So why should we have to learn chemistry? I mean, most adults don't use chemistry in their everyday life at their jobs, right? However, most high schoolers don't know what they want to do in their career. A large part of your education is exposing you to lots of different fields, disciplines, and possible occupations to help you figure out what you are interested in and what you want to be spending your life doing. If you never had to take chemistry, you might miss out on something that you actually really enjoy. These are all the degrees and occupations that require a good understanding of chemistry and that are all connected to chemistry and would require a decent amount of chemistry classes in college, if not a full chemistry degree, in order to actually be successful in all of these different occupations and jobs and careers. I often like to insert funny pictures and memes into my lessons, illustrating a point. If you want to do anything in med school or anything related to medicine, you're going to have at least a couple of classes, if not a degree in chemistry. Pretty much anything related to science, you're going to have to do a lot of math for. So keep up your math grades as well. All right, even if you already know what you want to do in life, and you know that it has nothing to do with chemistry, it's still a very good idea to have some knowledge and understanding of chemistry. Or let's say at the end of this year, you realize you never want to take another chemistry course again. You really don't like it. And so you're going to try to find a career that stays as far away from chemistry as possible. This year will still not be a waste. For example, just because many people don't go into politics doesn't mean that they shouldn't study government and economics. Having a good understanding of how our government works helps us to make informed decisions as adults. In the same way, having a good understanding of chemistry helps us to think critically, spot misinformation, and not get scammed or fooled by things we see on social media. So, for example, let's read this infographic. It says, "This is rust. It's caused by oxygen and called oxidation. We breathe oxygen every day. If it can do this to a chain, just imagine what it can do to your lungs. Share to help raise awareness about the danger of oxygen. Okay, so we can tell right away that this is satire. But we only know that because we are familiar with the word oxygen. Oxygen is a word we've used in our everyday lives since we were very young, and we know that our bodies need oxygen to survive. Having said that, every word on this picture is in fact true. Oxygen does cause iron and many other metals to rust, and this process is called oxidation. We also know that we breathe oxygen every day. But to act like just because oxygen can destroy these chains made of hard metal, that somehow it will be much worse for our lungs, is a false equivalence. This conclusion, that it would be worse for our lungs, is based on false reasoning. But the author is hoping you don't understand that oxygen reacts very differently with our lungs than it does with metal. An understanding of chemistry would help us understand that. Here's another one. Water bottles stored on grocery store shelves for more than 1 month have been found to contain very high levels of dihydrogen monoxide. Now, if you're like many people, you probably don't know what dihydrogen monoxide is, and this might sound serious. If you do know what dihydrogen monoxide is, then you realize that this is also satire. But before I explain, let's look at a couple more. Okay. So let's read this one. Dihydrogen monoxide is an acid with a pH level of 7. That's a higher pH level than any other acid. Okay, so maybe you know what dihydrogen monoxide is, but you're not sure about acid-base chemistry, and this could sound a little concerning. By the way, everything on this image is factually correct. In a later chapter, I'll teach you all about acids and bases so that you can understand that you shouldn't be concerned here, or worse, fooled by words like these. And here's this last one. Dihydrogen monoxide. Inhalation, even in small quantities, may cause death. Prolonged contact with its solid form results in severe tissue damage. It may cause diaphoresis, micturition, and acute tissue hydration. Okay. Let's learn what dihydrogen monoxide is because this sounds like pretty awful stuff. So as we'll learn in our nomenclature lesson, or on our lesson when we learn about how the chemical compounds are named, the prefix di means two. And of course, hydrogen is the element hydrogen from the periodic table. It has an H for its symbol, capital H. There are 2 of them, so we write a subscript 2 here. Mono is a prefix for one, and then the oxide comes from oxygen, so we have 1 oxygen. This, my friends, dihydrogen monoxide, is simply water. It is just H2O. So let's look back at a couple of these here. Water bottles stored on grocery store shelves for more than 1 month have been found to contain very high levels of water. Yes, in fact, that would be true, and it would be expected that those water bottles would still have very high levels of water, even just after 1 month. But you can see how the author was trying to fool you into thinking somehow dihydrogen monoxide was some scary compound that was gonna just somehow seep into your water bottles after a month. Water is in fact an acid with a pH level of 7, and we'll find, if you don't already know, that the pH level of 7 is neutral, but even though it can still be considered an acid. Acidic pH levels are lower levels. So this pH level of 7 is in fact higher level than any other acid, but that actually means it's less acidic than any other acid. And so the way it's wording here is it's praying and hoping that you don't understand acid-base chemistry. And you don't understand that actually the lower levels of pH are the more acidic and potentially more dangerous, not the higher ones. And so it's assuming you don't understand chemistry to try to fool you into thinking that this dihydrogen monoxide is much worse than it is. So now let's look at this. We are going to talk about inhalation. If you inhale some water, even in small quantities, that's going to cause death. It may cause death. That's basically drowning. If you get a lot of water in your lungs, not good for you. If you have prolonged contact with its solid form, so ice, on your skin for a very long time, will definitely result in severe tissue damage. Diaphoresis is the, scientific medical word for sweating, and micturition is urination. So yeah, if you drink a lot of water, you're going to be sweating a lot and urinating a lot, and neither of those are bad, obviously. So while these infographics that I just showed you were all created with the intent of satire and to be silly, many companies try to scam or fool you into believing something that isn't true by using these very same tactics, hoping you don't understand chemistry or some other complicated science so that you will believe a specific ingredient is bad for you or a specific activity is bad for you and end up purchasing their products instead of someone else's. Of course, here's another good meme to illustrate this point, and being careful of what kind of research you do and where you do your research. Here's another practical reason to understand some chemistry. Many people in the wellness industry scare their clients and customers into believing that if they can't pronounce the name of an ingredient, then it somehow must be bad for you. But as you'll learn in our next chapter, every single compound has a systematic chemical name, even water, as we just saw. The difficulty or complexity of the name or the pronunciation has absolutely no bearing on the safety of that ingredient. To illustrate this, look at these two ingredients lists. The one on the left is obviously a very long list with complicated sounding chemicals, some of which I would even have a trouble pronouncing. The health and wellness industry and even diet culture has conditioned society to believe that a shorter list of ingredients, as well as an easier to pronounce list of ingredients, is somehow an indication of a healthier food. Can you guess what these two items are? You see, every single thing that we eat, touch, breathe, and see is made up of chemicals with complicated sounding chemical names. A chemical is not inherently bad for you. So now you have an understanding of why it's important to learn some chemistry. Even though I know most of you will probably never use chemistry in your adult life. I hope you still enjoy all of these chemistry lessons with me.